Welcome back, everyone, to the eCoreAcademy e-learning platform today. My name is AJay back with yet another geometry video for you all. And today's lesson topic is all about inverse trigonometric ratios. That's going to be following our trigonometric ratios video. So that's a predecessing video. I highly and strongly recommend that you go and watch that video before watching this one. There's a lot of background information and a lot of preview coming into this topic all about trigonometric ratios. It's a very important topic, something that you might not even cover in geometry, but it is a geometric concept, and it's a very popular unit to be taught all throughout geometry. Very difficult. That's why a lot of times your schools might push them into your Algebra 2 courses and even your pre-calc courses. But here in geometry, as an enrichment platform, we're going to get through all of these difficult topics ahead of time so that you can expendage and get ahead, essentially, and explore many of the more math topics that are going to be offered, such as college level math in high school. So that's a way for you all to get ahead of the game. But before we jump into today's video, please make sure to smash that subscribe button down below. Hit that like button on this video, as well as turning on post notifications by clicking that little bell icon right next to the subscribe button. All four of those things are very greatly appreciated, as well as commenting down below. Sharing your feedback is very essential for us, so we can try and implement those in videos to come. So our lesson purpose and our goal that we're going to reach in this video, our objective, is we're going to take a look at trigonometric ratios, our previous video. I'm going to try and give some insight into those trigonometric functions, and later we're going to see how exactly we can discover their inverses and how their inverses can be utilized. If we date back to our geometric reasoning and geometric statements videos, I talked to you about basically conjugating and congregating your different types of statements. Meaning conjugating, we're going to depend on a certain situation. You're going to alter your case, or say, for example, your equation, and trying to ease that by looking at what type of variable that you're trying to expendage and calculate for. But in this case, we're actually going to be looking at the inverse. So we're going to look at the converse of each of these trigonometric ratios and plug them in for different utilizations and different purposes with the same goal in mind. So without further ado, let's jump right into it. Let's look at inverse ratios part 1. Let's look at reapplying trigonometric ratios in a different manner. So this is going to apply to different types of problems, as I will explain to you here what types of problems are going to be applying to and how they're going to compare to your traditional trigonometric ratios. So sine, cosine, and tangent ratios relate to right triangles, as they are the ratios of two sides and one of its acute angles. So they're not for obtuse or acute triangles. So essentially what sine, cosine, and tangent functions are is that they're ratios relating side lengths of triangles. And those relations can not only just apply to your given side lengths, but they can also apply utilizing their inverses to calculate missing angle measures. And that's going to be the goal for today. So the inverses or direct opposites of these ratios will apply to different types of problems. When you're given your traditional trigonometric ratios, what you're going to be doing is you're going to look at solely the side lengths. So you're not necessarily going to pay attention to the angles. What you're going to do is you're going to try and utilize your ratios, such as h over o, h over a over h, O over h, A over h, and O over a, or vice versa. You're going to try and utilize those ratios in order to calculate your ratios and missing values in your side lengths. And you're also going to try and calculate your missing angle measures. That's how you're going to utilize it. Once you develop your ratios, say, for example, we have over here O over H, and O over A, and that's going to be a tangent ratio for this theta angle here. So it's going to be O over A. Now that's going to equal a given ratio. So you're going to have O over A equals your ratio. And all you do for that ratio, that simplified ratio, is you're going to multiply it by your tangent. Tangent. So you're going to multiply it by your tangent ratio, and this is your regular tangent function. You're going to multiply it by that given ratio in order to be given the given value of your theta, your central angle in degrees for this problem. But now we're going to be working backwards. This tangent ratio, O over A is this tangent ratio is going to be O over A equals your ratio. Tangent times the ratio equals your theta, central angle in degrees. Or so you might think. But today we're going to be looking at how you're going to multiply it by a negative first power. So in this case, we're going to look for that missing angle measure. This is not how you're going to traditionally set up your equation. What you're going to do is, for your traditional equations, you're going to actually be given a central angle. You're going to be given your central angle here. Say, for example, it's 30 degrees. And then what you're going to do is, instead of doing this, this is what we're going to utilize today. We're going to use our side lengths, develop a ratio, multiply it by an inverse function of your trigonometric ratios in order to find the value of your central angle. And that's very key. But now, what we did in our previous video, what your traditional trigonometric functions are going to be valued for, and what they're going to be developed and purposed for, is basically the complete opposite, the inverse of what I'm showing you here. So instead, you're going to be given your central angle here. Say, for example, let's say that that's 30 degrees. Theta equals 30 degrees. And once you're given 30 degrees, what you're going to do is you're going to multiply by one of your functions. So in this case, we want to calculate between A and O. So that's going to be a tangent function. Remember, it's going to be adjacent and opposite. So it's going to be opposite over adjacent. So 30 degrees equals your theta. Afterwards, you're going to multiply this by tangent function by 30 degrees. And then afterwards, what you're going to do is, if you're given only one value of A or O, if you're only given one value, say, for example, you're given tangent of 30 degrees and it's going to be O over A, you would want to multiply this by A in order to get O. Vice versa, you would want to divide this. You would want to divide O by tangent of 30 in order to get A. But now we're going to look at the opposite way. We're going to repurpose this in an opposite manner. Just as negative, your minus sign is the opposite of your plus sign, used for different purposes and convenience in that matter. That's exactly what we're going to be repurposing today in terms of our inverses. So inverse ratio is part 2. Let's look at the tangent inverse. So there's 3 inverses of our 3 trigonometric functions: tangent, sine, and cosine. So if you recall, tangent, it's your adjacent side over your opposite side, and that relates only to your acute angle of your given right triangle. So the tangent inverse states that the angle that has a given value as its tangent ratio, as it is signified by tangent to the negative first power, which is known as arctangent and is abbreviated as arctan. So the tangent inverse is when you're trying to calculate for the missing angle measure, and that angle measure is going to be identified by the ratio multiplied by your tangent to the negative first power, which is just your inverse, tangent exponent -1. And it's abbreviated or called as arctangent or abbreviated as arctan, as opposed to tangent and tan. When plugging this into a calculator, all you're going to do is click on the tangent to the -1 rather than tan, and afterwards you're just going to plug in your given value, your given ratio, after dividing your side lengths across. So in this example here, we have 5, 4, and 3. All we're going to do here is we're going to plug in our values for this example here. So since it's a tangent ratio, I want to calculate for angle P here. And tangent ratios are opposite over adjacent, so it's going to be 4 over 3. So we're going to divide 4 over 3. Since it's already in its simplest improper form, we're going to leave it as 4 over 3. And then what we're going to do is we're going to multiply it by our tangent to the negative first power by 4/3. And that's going to equal P, or our theta here. And I will show you how to utilize the calculator part later on. I'm just going to show you how to set up the equation, but don't worry, I will show you how to plug that into your calculator. This is just going to be a calculator's work, how you properly plug it in, not something that you can calculate on your own. Moving on, inverse ratios part 3. Let's look at the sine inverse. So the sine inverse is the angle that has a given value as its sine ratio, as it is signified by sine to the negative first power, which is known as arcsine, which is long for arcsine. Basically, your abbreviation, just taking off that one E at the end. So if we recall our sine trigonometric function, your sine function is merely your opposite over your hypotenuse. Remember, hypotenuse is never going to be dividing another number, or another value. Therefore, sine is always going to be a decimal. Just keep that in mind. I referred to this in my previous video, just so that you guys get a recollection. Sine is always going to be a decimal, as is cosine. So cosine's adjacent over hypotenuse. It's also going to be a decimal because hypotenuse is the largest value. However, your tangent function, it can vary depending on which angle measure you're looking at, meaning you can have a larger, you can have a whole number or a decimal or a decimal that is greater than 1. And when plugging this into a calculator, click on sine to the negative first power, right, rather than sine. So that's inverse of sine, rather than the sine value. And all you're going to do is multiply that to your ratio. So utilizing this same similar triangle here, we're also going to utilize angle P, which is one of two of our acute angles here. So the sine, if we're trying to calculate for our sine here, calculate for angle P, and we want to use our sine inverse, we're going to do opposite over our hypotenuse. So that's going to be 4 over 5. So 4 over 5, we're going to write it here. Since it's already in its simplest improper form, we're going to leave it as such. It's much easier to do this when plugging this into calculators. Otherwise, I would most likely recommend putting this into decimals or either into your mixed numbers. So now, since we've calculated our ratio, which is opposite over hypotenuse, we're merely going to multiply this by sine to the negative first power. So it's going to be sine to the negative first power multiplied by 4/5. And that equals P or theta. Just want you guys to get used to this theta term, our central angle or angle of focus. Moving on to cosine ratios, so inverse ratios part 4, and our cosine inverse. Let's look at exactly how that's going to relate to the cosine trigonometric ratio. So the cosine inverse is the angle that has a given value as its cosine ratio, as it is signified by cos to the negative 1 or cosine to the negative first power, which is known as arc cosine or arc cos. And when plugging this into a calculator, you're just going to click on cosine to the negative first power rather than cos or cosine. Looking at this example here, we recall that cosine is going to be your adjacent over your hypotenuse. So we're still going to utilize P as our central angle or theta. And we can see here that our adjacent side has a value of 3, side PQ. And we're going to divide that by our hypotenuse, PR, at 5. So that's going to be 3 over 5. Just make sure that you guys recall your cosine is always going to be a decimal. So the inverse of it is still going to be a whole number. So it's going to be a number, much larger than 1 degree because it's an angle measure. And that's what the inverse does. It actually will always increase your number, your value. So 3 over 5 here, and that's going to simplify to 3 over 5 in our improper form. And then we're going to take cosine to the negative first power, multiply it by 3/5. And that's going to equal P or theta. And when it comes to calculators, it's not so difficult when it comes to the calculator portion, because scientific calculators, no matter what type, which I will explain in the next slide, what type of calculators you need, but trigonometric calculators, any scientific calculator will have these values automatically. So you'll have a cos ratio, or you'll have a cosine ratio, or you'll have calculators, which I will be using today to show you, in which you can just merely raise your given ratio to the negative first power and multiply it. So they're already inputted into the calculator. So let's look at utilizing a calculator. Very important for this lesson. Adding inputs to calculate ratios. A scientific or graphing calculator can be utilized to calculate trigonometric functions and their inverses. So the link is in description. I will add the calculator that I'm going to be using. It's a school calculator that I use. It's called desmos.com. I also do have a personalized graphing calculator. I highly recommend those as well. Get used to those because you're going to be utilizing them in Algebra 2. But I just want to use it because in my opinion, it actually has all the numeric values open for you, and it's much easier to show to you and utilize. So in a calculator, put the settings to degree mode. Make sure it's in degrees, not radians. And then click the desired trigonometric function, which is, cosine, tan, or sine. And if you want to do an inverse, which we're going to be doing today, all of today, and you're just going to raise it to the negative first power if it doesn't automatically have your inverse functions inputted as buttons on your scientific calculator. And you're going to follow it by the angle of focus or the angle of elevation, which is basically the ratio that you discovered in order to calculate that given angle. So that's that. Now let's jump into our practice problems. Practice part 1. Let's solve the problems utilizing a calculator. This is our calculator section. So let's look at this example here. This example here, I'm going to utilize this angle here, over here on this bottom right corner, and we're going to utilize our tangent function. So this is going to be tangent. Wink, wink, tangent inverse. So tangent. We look over here, it's going to be adjacent over opposite, so it's going to be 4 over 3. And that simplifies to 4 over 3. And now what we need to do is we're going to do tan to the negative first power multiplied by 4 over 3. Now I'm going to switch to my calculator over here. So now we're going to input that into our calculator. So we look at our calculator here, we know that our value is 4 over 3. That's our ratio. So now what we're going to do is we're going to use tangent to the negative first power. So we have this tangent button here. And then all we're going to do is click on the tangent and raise it to our negative first power. Unless, of course, your calculator automatically has that. But I want to show you how that's being made up. So that's 4 divided by 3. So tangent of negative 1 multiplied by 4 thirds. And that's going to equal 53.13. We're going to round this off to our nearest hundredth when it comes to our trigonometric functions, especially when it comes to our angle measures when calculating these inverses. Let's switch back to my screen. So that's going to be 53.13 degrees. Moving on to the next problem, we have this obscure right triangle, not your traditional right triangle in which your side length is going to be your height, but it is still a right triangle. In this aspect, we're going to look at this this ratio here. This 5 here in this example of 5, this whole portion here, this small triangle portion here, is actually going to be irrelevant in this case because it's not a part of this right triangle that we're associating here. So we have 9, 4, and 12. Our angle of focus is going to be right here. And now we're going to look at our sine inverse ratio. So we're going to inverse our sine. Sine, if you recall, is opposite over hypotenuse. So it's going to be 4 over 9. So 4 over 9 equals 4 over 9, simplified in proper fraction form. So that's 4 over 9. So we're going to multiply by sine to the negative first. So sine to the negative first times 4 over 9 equals our value. So let's switch back to our calculator here. Now we're going to do a sine function instead. So it's going to be sine to the negative first. So we're going to raise it to the negative first power. We're going to multiply it by 4 over 9. And then again, I really strongly recommend this website. It's so good for these trigonometric functions. And a lot of other calculators can be a pain in the butt. It doesn't save your answers, but this does, and it saves it in lists. So if you want to type something else here, like 8 plus 9, 17, it saves all your answers in lists, so you can just copy and paste them down below. But focusing on this, sine to the negative first power times 4 nines is 26.39. We're rounding to the nearest hundredth. So it equals 26.39 degrees. Let me just mark these off as our theta, our angles of focus. All right. Moving on to our last problem, solve the problems calculator. This is our last problem. In this problem, we're going to be utilizing our cosine function, so our cosine inverse ratio. Let's utilize this angle right here, this farthest angle, as our angle of focus, our theta. And we recall that cosine is going to be our adjacent over your hypotenuse. So it's going to be 12 over 13. This is 12 over 13 equals 12 over 13. That's its simplified and proper fractional form. And then we're going to multiply cosine to the negative first power. Remember, on a scientific calculator, it's always going to be shown in its abbreviation, not its full form. That'd just be irrelevancies. You're not going to really see cosine out there too much unless it's a historical or an informational lesson such as this. You're going to most likely see its abbreviations. You're not going to see it stated as arc cosine. It's just going to be cosine to the negative first power. It's mathematical form. This is going to be cosine to the negative first times 12 over 13 to get our answer. Now we're going to plug that into our calculator here. So it's going to be cosine to the negative first power, cosine. Raise that to the negative first power. And I'm just clicking on the A to the B power, B being any digit that you want it to be or any value that you want it to be. And we're going to multiply by 12 over 13. Add our closing parentheses to be organized. And that's going to be an angle measure of 22.62, rounding to the hundredth once again. 22.62 degrees. And we're done. Once again, everyone, I hope you guys enjoyed this video. This has been the eCoreAcademy e-learning platform. Before you leave, please make sure to like and subscribe down below. And of course, hit that post notification bell so you don't miss out on any of our latest uploads. And feel free to utilize that comment section down below. We really do pay attention to what you put down, and we'll try and respond as quickly as possible. Please check out our website at www.ecoreacademy.org. That is full and unlocked access to what we as an online e-learning platform actually offer for you. We have full unlocked access to our integrated note sheets, worksheets, and quizzes that go along with each and every single one of our videos, organized into their own separate lessons under their own subject and course category. So don't miss out. All you have to do is make a free account there. You get access to such things such as our progress checks and many other tips and tricks. Also, feel free to email us at eCoreAcademy@gmail.com if you have any questions or if you just want to reach out. That'll also be in the link in the description down below. And I will also link the calculator website, a scientific calculator at Desmos. They also have a graphing calculator and many other features. I highly recommend utilizing that. It's for free completely. And finally, visit all of our socials. Full link is in the description at Facebook, Twitter, and Instagram. See what kind of content we have there and use those mediums to share all of our videos. Once again, everyone, I hope you guys enjoyed. This has been AJ. I had a blast making this video. I hope you enjoyed, and I will see you guys in the next one. Peace.